Hello, today we're going to look at identifying the shape of different polygons on the coordinate plane. So here's our first example. It says, what is the most specific name for the quadrilateral with the following vertices? We have A at 0, 0, so I'm going to draw a mark here at 0, 0 for A, 2, 4 for B, 6, 4 for C, and 8, 0 for D. And I'm going to connect my lines. Okay, and so just eyeballing it, it looks like a trapezoid. I can't go off looks though. I'm going to have to do some actual calculations. So the best thing to always do is to start off by finding the slopes of each line to see if they're parallel sides. We know that quadrilaterals have specific quadrilaterals have parallel sides, perpendicular sides, and things of that nature. So the first thing we'll do is find the slope. So I'll find the slope of AB first, and just recall slope is y2 minus y1 divided by x2 over x1, or it is the change in y over the change in x, or rise over run. Okay, I'm going to use this formula here. So we'll do the slope of AB, and just because I named it AB, I'll make B my second point. It doesn't matter which one you make the second point, you're going to get the exact same answer every time. So with B being my second point, my y2 is 4 minus 0, which is my y1, over 2 minus 0, and I get 4 divided by 2, or 4 over 2, which is just plain old 2. Alright, then we'll do the slope of CD, and again we'll say D is our second point just because I named D second, and so D is y2 is 0 minus y1, which is 4, over x2, which is 8, minus x1, which is 6. And so I get 4, or negative 4, over 2, and that gives me negative 2. So these two sides are not parallel. Let's do BC. So BC, my second point will be C, so that would be 4, y2 is 4, minus y1, which is 4, over 6 minus 2. I can really stop here. 4 minus 4 is 0, so I get 0. That slope is 0. We'll do AD now. So this section here, and it's pretty obvious that this is 0 because this is a horizontal line, and we know horizontal lines have a slope of 0. So this one most likely will be 0 as well. So D is 0 minus 0. I can really stop there, but we'll keep going. 8 minus 0. So we'll say that slope is 0. So these two sides are parallel. So we have one pair of parallel sides. So we can say that it is a trapezoid, but is it a, and we also know that there's no right angles because we did talk about right trapezoid. They're not meeting at a, nobody's meeting at perpendicular. So this is just a trapezoid, but now we have to determine if it's an isosceles trapezoid. So let's look at the side of AB and CD and see if they're the same by using our distance formula. So we have distance from A to B, and the formula is x2, so we'll say B is my x2, so we'll say 2 minus x1 squared plus y2, which is 4, minus y1 squared, and I get 2 minus 0 is 2, so 2 squared plus 4 squared. We get 4 plus 16, so that's the square root of 20. I can leave it right there. I just want to see if I get the square root of 20 for CD as well. So let's do CD. Alright, so x2 is 8 minus x1 is 6 squared plus x2 is 0 minus 4 squared. Eight minus 6 is 2, so 2 squared plus negative 4 squared. And so I get 4 plus 16, which is the square root of 20. So they're equal. So this is not just a trapezoid, this is an isosceles trapezoid. Okay, let's go to the next one. It says, what is the most specific name for the quadrilateral with the following vertices? So we have 0, 1 is M. We have negative 1, 4 is N. P is at 2, 5. Q is at 3, 2. Alright, so the first thing again, like I said before, the best thing to do is to find the slopes. So we're going to start off with the slopes. We'll start off with M and N. So that is 4 minus 1 over negative 1 minus 0, which is 3 over negative 1, which is negative 3. Alright, let's do PQ. Q first, well, it's my second point, so that's going to be 2 minus 5 over 3 minus 2, which is negative 3, over 1, which again is negative 3. So these two sides are parallel. Then we can do N and P. P is my second point, so we'll say 5 minus 4 over 2 minus negative 1, so that's plus 1. And that gives me 1 over 3. So it looks like not only, so we get 1/3, so that means this is perpendicular to these two lines. And then we'll do MQ. So Q is my second point, so we'll say 2 minus 1 and 3 minus 0. And I get 1/3 again. So these are parallel and perpendicular. So we know that it is a parallelogram because we have two pair of parallel sides, and we also know that it has to be a rectangle, at least minimally, because they intersect at a right angle. Now we want to determine if it's a rectangle or a square, and so let's look at the diagonals instead of determining the sides of them. It's probably quicker to look at the diagonals to see if they intersect at a 90-degree angle. So we'll find the slopes of the diagonals. So let's find the slope of MQ. Excuse me, NQ. So we'll say Q is our second, so that's 2 minus 4 and 3 minus -1, so that's +1, which gives me -2 over 4, which is -1/2. All right, so we did NQ, let's do MP. MP, so P is my second, so that's 5 minus 1 and 2 minus 0, which is 4 over 2, which is 2. And so these are the negative reciprocals of each other, so it does intersect at a 90-degree angle. So this is a square. All right, the next one, we have 3 points, so it definitely is a triangle. So let's plot our 3 points. We have -4, 6. Oops. Oh, 4 is over here, I'm sorry. 4, 6. And 0, -6. All right, so this is a triangle. I can tell by the way that it looks, even though I don't always want to go off of looks, and also the way that the points are set up, that this is not a right angle, a right triangle. Let's see if it's an isosceles triangle though. So we can find the distance from this point to this point, and then from this point to this point. So we'll find the distance first from -4 to 0, -6. So we'll do 0 minus -4, so that's +4 squared plus -6 minus 6 squared, and that gives me 16, and then this is negative minus, so minus 6 is a -12, so a -12 squared gives me positive 144. And so that gives me the square root of 160. All right, let's look at the other one. So from 4 to 0, 6 instead. So we'll do again 0 minus 4 squared plus -6 minus 6 again. So it looks like already I can tell that it's coming out to be the exact same, because I get a -4. -4 squared gives me 16. -6 minus 6 is -12. -12 squared is 144. And again, I get the square root of 160. So these are equal. We can test to see if this intersects at a perpendicular angle. I highly doubt it, but that's something that if you want to test, you can do that. But I will say this is an isosceles, and there are isosceles right triangle. But I think this is as far as we'll go for this one. And I hope that this helps.